Hello class, today we're going to look at piecewise functions, the thing everyone hates. We're going to try to make it short and sweet, so this is something you can digest in nugget form. And we're just going to, I'm going to kind of make it up as we go along, but hopefully it'll be valuable. So a piecewise function, just in general, is made of pieces. So made of pieces of multiple functions. So they're functions that you wouldn't be able to make one function for because it's shaped so oddly. Alright, so they look like this in general. F of x equals, and then it has room for however many pieces you want to do. We're going to do 3 today, just because I've never really seen any past 3. And we're going to try to fill it up with very different looking functions. Actually, we might even do 4 because there's one that confuses everyone. We'll start out with a line, and what I'm going to do is I'm going to write the linear function inside, and then in gray we're going to graph the entire function as if it had no domain restrictions at all. And we'll see what it looks like, and then we'll add in the domain restrictions and see what that does. So let's do just a simple line, maybe 1/2 x minus 3. Okay, so if I were to, this is all a piecewise function had. It would just be the normal function y equals 1/2 x minus 3. I would start here at -3. I would go up 1, right 2. This is something you can do just right in your calculator. So this is the entire thing. Arrows on the end and everything. Looks like this. So that's if there was no domain restriction at all. But now we're going to add a domain restriction. We're going to say that we want this between, how about -8 and -3. Actually, let's do, I lied, let's do -8 and -2. And you'll see it written in interval notation like this most of the time. And you have to keep your eye on whether it's equal to 8 or -8 and -2 or just less than or greater than. So that means I'm going over here to -8 and -2. I only want this section of the line. So from here to here. So I'm going to color that in with orange. And I'm going to erase the rest of it, because the domain restriction is telling me that this piecewise function looks like 1/2 x minus 3 from -8 to -2. Everywhere else, it's not defined. It doesn't exist. So I'm going to erase there. I'm going to erase over here. I'm going to erase these little marks I made. There we go. Alright, we're going to do something else now. We're going to do a little quadratic action. I want to do something very uncomplicated. X squared minus 1. Alright, so this is the normal. Normally this function would be y equals x squared minus 1. Remember, the parent function x squared is just a normal parabola with the vertex on the origin in the middle. Minus 1 just drops it down 1 notch.
Okay, ASAP, you may switch to first session.
Did you hear, Miss O? ASAP has to go to first session, in case you're here still. So we drop it down 1, and now obviously you can use your calculator for this, but it's pretty easy to do in your head too if you think about it. 1, if I go to x equals 1, 1 squared is 1, minus 1 is 0. And remember, it's symmetric, so I can just graph either side both times. 2 squared is 4, minus 1 is 3. So if I go right 2, I have to go up 3. And the same thing on this side. And we'll do one more. 3 squared is 9, minus 1 is 8. And again, like I said, use your calculator if you're not understanding how I'm getting these numbers in my head. So this is actually what the parabola looks like. And I meant to do this in gray, I just realized. So I'm going to pause it and it'll appear in gray in a second. Okay, there it is. I have the arrows on there because parabolas go on forever. Again, without a domain restriction, that is what this function looks like. But we want, in blue, I'm going to add it in. Let's say so that this stays a function, I'm not going to overlap things. We're going to say from -2, but we're not going to include -2 because it's already included up there. And then x is less than or equal to, oh, I don't know, how about 3? Make sure it's easy to graph. So at -2, we have this dot right here. But we want an open dot. So I'm going to undo that, what I just did. Make it a nice open dot. And then we want to go all the way to 3. 3, so this was -2. This was 3. So I want to go up here. This one can be a solid dot. And then we're going to graph all of this. Alright, and I can get rid of the rest. I can get rid of my marks I made. Get rid of the left part. I'm going to get rid of the right part. Try to sneak it in without erasing my functions. There we go. Let's see, another part here. We need... Why don't we just do one of those pesky plain old numbers? It looks like this. -3. So a lot of people look at that and say, what the heck am I supposed to do with a -3? That doesn't look like a function. Well, remember, it looks like this. Y equals -3. And you can actually graph that right in the calculator. You can just type in -3 on one of the y equals lines. You can't type in x equals, but remember, y equals go like this. Just as a side note, x equals, let's say 5, are vertical lines. But that's for another lesson. So this is going to be a horizontal line where y is always -3. I don't really need to make dots. That's just this line. I'm going to follow that grid line at -3. And again, that's if I had the entire thing, and again, I was silly and I was supposed to write it in gray. So let me fix it. There we go. I'll write it in gray at first. And we're going to make a new domain restriction. We're going to say from, where did I end? I ended at 3. So we'll say x is greater than 3. So this one's a little different because not only do I have an open dot on 3, it's just x is anything bigger than 3. So I'm going to keep my arrow right here, but I'm going to erase everything to the left of that. Make a smaller one here. There we go. So this is what the piecewise function looks like. It's rare that they will actually have you graph a piecewise function. I don't see that on the regions very often, but they do love asking questions about piecewise functions. So chances are they'll give you this whole thing. They'll just give you this and then ask you questions about it. Let's get some things that we know extracted from this. First of all, they love to do this. Hey, what's f of 5? And you're saying, well, I could plug in the 3 different things, but the domain restrictions tell you where it should go. So since x is greater than 3 is one of the domain restrictions, and 5 is greater than 3, then I plug it into this. And there's really nothing to plug it into. There's no x on the -3, so you just say f of 5 equals -3. You can't really plug 5 into it. If you go to, you can look at it on the graph though. If you go to the right 5, 1, 2, 3, 4, 5, you can see right here that that's the value. So that's f of 5. Let's say I had f of 0. Alright, well, where does 0 live? 0 does not live between -8 and -2. It does live between -2 and 3. So I'd plug it in to this one. Oops, wrong arrow. Look at that. Fixed it. So I'd plug 0 in. 0 squared minus 1 is 0. Or you can just look over here and say, okay, 0, here's where I am. So this is f of 0, and I'd see that the value is -1. Alright, then finally, what if I had f of negative 3? Okay, so I look at negative 3 on the graph, 1, 2, 3. I'd be right here. Negative 3. I think that's negative 1, 2, 3, 4.5. But since my graph wasn't perfect, I'm going to plug it in to make sure. So it'd be 1/2 times negative 3 minus 3. Half of negative 3 is negative 1.5 minus 3, and that was right. It's negative 4.5. And that one got plugged into up here. So remember, these are x values. They tell you what part of the domain it lives in the piecewise function. And your domain restrictions say where all your x values live. So that's the basics. Hopefully that helped a little bit. If you want any more examples, let me know when you come into class, and maybe I'll post an example where you can try it yourself, and then I'll put the answer up. All right, bye-bye.